I want to talk about this rule right here. On page 3, I plus 1 over S angle NI equals 1 over A angle NI. And let's say, see page 3A. I want to talk about that rule on page 3A. I'm going to create page 3A right now. There is no 3A yet, right? Okay, good. So I plus 1 over S angle NI equals 1 over A angle NI. Borrow $1 at t equals 0 for n periods. There are two options for paying back this loan. Option 1, here's the $1 that I borrowed. The $1 comes into me, and I pay back some amount at time 1, some amount at time 2, some amount at time 3, ... some amount at time n. Can you give me the present value of these payments in terms of Q? I want the time 0 equation of value. Can you tell me? What's going on? Can you tell me the present value of these payments in terms of Q? Bring everything back to 0. That's what I'm asking you to do. So I borrow $1 at time 0, right? Here's the dollar that I'm borrowing. And I intend to pay back this loan over n periods with a payment of Q. I'm asking you, can you give me a time 0 equation such that I can find Q? I can solve for Q. Any idea? Yeah.
Would it be 1 equals negative Q times B plus B squared plus up until B to the n?
Which is called what?
The discount function?
Which is called what? Didn't we have a symbol last class for the present value of a payment of Q? One payment at time 1, one payment at time 2, one payment at time n. What is that called? There's a short way to say that, right? A angle NI. Yeah? So I'm going to say 1 equals Q A angle NI. Meaning that I have payments of Q, I have an annuity immediate, this is my annuity immediate right here, at some interest rate I, and the present value of that is equal to 1. Does that make sense? So how do I solve for Q? Q equals 1 over A angle NI. By the way, that's the right-hand side. That's one option for paying back this loan. Right-hand side. The other option for paying back this loan is to not pay back any part of the principal as you go along. only pay back interest. Option number 2, at time 0, I borrowed 1. At time 1, I'm going to pay back only the interest on that 1. At time 2, pay back only I. At time n, pay back only I. So you are keeping the lender satisfied by paying him the interest every year, but you're keeping the principal. And you will pay back that principal at time n. It's like if you borrowed $100,000 from your parents, right? And you said to your parents, you know what, parents, the bank is only giving 2.5% right now. I will give you 3%. And I will give you 3% every year. So you borrowed $100,000, you're going to pay them $3,000 every year. Just keep them happy by giving them the interest. But you're holding on to the principal. Eventually you have to pay back that principal, right? At time n. So not only will you pay I every year, but you will pay starting at time 1, time 2, time 3, some R into your own savings account such that these R's accumulated value equals 1. Does that make sense to you or no? Look, eventually you have to pay parents back $100,000, right? So you have to start collecting some money in your bank account such that that accumulates to $100,000 at time n.
Would for option 2, wouldn't it take longer?
Why?
I don't know, I feel like
They are equal. They are equal. I'm telling you that when you take a loan, you have 2 options to pay back that loan. Either you can pay back Q, which is equal to 1 over A angle NI, which is equal payments, n periods, equal payments of amount Q. Or you can say to the lender, listen, lender, I'm only going to pay you interest every year. At time n, I will pay you back your $100,000.
would that at time n be equal to
The payments would be equal. The payments have to be equal, right? So what is R is my question. So I've come up with this equation that says that if I put in my bank account an amount of R for n periods, these R's will accumulate to an amount of 1 at time n. Of course, for parents, it would be 100,000, so I would multiply by 100,000, right? Are you with me or no? So how do I solve for R? Tell me. You know how. We learned it last class. Can you find me an equation such that the accumulated value equals 1 of payments of R that go into some savings account? What's the symbol for the accumulated value of an annuity? Immediate. Yeah. Yeah, S angle N. So can I say R S angle NI equals 1? Therefore, R equals 1 over S angle NI. So now, this plus this is the total payment, right? So couldn't I say I plus 1 over S angle N I is the total payment? That's what you have to shell out every year, right? You have to shell out I for the parents, and you have to shell out R for the savings account. Make sense or no? So set this total payment equal to the payment for option 1. So option 1 payment equals option 2 payment. So option 1 payment was 1 over A angle NI, and option 2 payment was I plus 1 over S angle NI. Finished. Of course, you can show this mathematically too, but that's less interesting than understanding what the hell is going on, right? Anyone can plug in some formulas. The idea is to understand what is this saying in English, right? Or in any language for that matter, right? Any question?
The length of option 1 and option 2, are they always going to be the same?
Yeah. This can only be true if they are the same. So you're saying, hey, either I'm going to pay back the loan this way with Q's to the lender, or I'm going to keep satisfying him with I, and I'm going to put R in my savings account. So if these are two different options to pay back the same loan amount, then those two payments have to be the same. Yeah.
So is I and R are equal to each other, and like
I and R?
yeah, because like when you did like R S angle NI equals 1, and then you put an I in the next line.
Here?
Yeah, that's
So this I, no. This I is this payment that you're going to pay the lender to keep him satisfied. And this 1 over S angle NI is equal to R. And I'm saying that the total payment for the year or the period, total payment per period. And this is the total payment per period, option 1. Follow? Feel free to ask me if you're not happy with this scenario. I can explain. So this kind of reasoning is going to become very necessary later on when we talk about sinking funds. So a sinking fund is an account where you accumulate the total value of the loan like we are doing here. Keep paying the lender the interest and you accumulate the value of the loan and then pay back the value of the loan at the end of the period, right? So when we talk about sinking funds, I'm going to remind you, and it's going to feel like way back when you learned about this. Okay, so it's nice, it's good to understand this now. Okay, so let's say here level payments, level payments for both options are the same, are equal. Let's move on today to annuities due, which is on page 3. An annuity due is an annuity lasting n payment periods in which a payment is made at the beginning of each period. A basic annuity due is an annuity due with level payments of 1. Similar to annuity immediate, we will provide shorthand notations. The accumulated value of an annuity due lasting n periods with effective interest rate I per payment period is given by S double dot angle N I. Note that this gives the accumulated value of the annuity 1 period after the last payment. Let me draw a timeline so you can see what I mean. So at time 0, there is a payment of 1. Already you should notice the difference between this and annuity immediate, right? Because in the case of annuity immediate, look right here. This was an annuity immediate. There was no payment There was no payment at time 0. Here, there is a payment now. That's called an annuity due. So at 0, there's a payment of 1. At 1, there's a payment of 1. All the way to at n minus 1, there's a payment of 1. But at n, there's no payment. No payment. So I'm going to say 0 here, okay? Just so you can compare to the other one. And this accumulated value is equal to S double dot angle N at some interest rate I. So it's the accumulated value 1 period after the last payment. Whereas in the case of annuity immediate, let me show you that picture again. Here's annuity immediate. The accumulated value for annuity immediate was at the last payment. Here there was no payment at time 0, but there was a payment of 1 at time n. And for annuity immediate, you are taking the accumulated value at the time n, at the time of the last payment. For annuity due, that's not the case. This is an accumulated value 1 period after the last payment. Okay, next page, page 4. Let me start drawing some pictures so you can see. So let's call this 4A or 3B. Let's call it 3B, actually. Zero, 1 with a payment of 1, time 2 payment of 1, time n payment of 1. This present value is called what? A angle n I. So that is the present value at at 1 period before the first payment of a basic annuity. And 0, 1, 1, 1, 2, 1, n minus 1, 1 is the present value of n payment basic annuity at time of first payment. And this present value is called a double dot angle n I, as we just saw. Which do you think is bigger? Which is larger, A angle NI or A double dot angle NI? Say to make it easy, how about A angle 2I or A double dot angle 2I? Which do you think is bigger and why? Any idea? So here I have n payments of 1. Here I have n payments of 1. And I'm asking you which is bigger. And prove it to me.
Would A angle I without that be larger because they could be gaining more interest over the lender?
Who gets paid earlier? Money paid earlier is always worth more, right? So A double dot angle NI is the present value of a stream of n payments of 1. But every payment is 1 year earlier than the payments for A angle NI. So would you rather have a payment a year from now? If I was going to give you $500 for your birthday, would you like it today or would you like it a year from now? Today. So who is worth more? The answer is A double dot angle N is worth more. How much more? The difference is a factor of 1 plus I more. So let me show you that with A angle 2. Very easy to show, right? So here's A angle 2I. There's a payment of 1 at 1, and there's a payment of 1 at 2. And this present value right here is A angle 2I. So can I say that A angle 2I is V? That's the present value of this payment of 1 plus V squared, which is equal to V times 1 plus V. And then there's A double dot angle 2I, where there's a payment of 1 at time 0, and there's a payment of 1. Let me just separate this. So there's a payment of 1 at time 0, and a payment of 1 at time 1, and no payment at time 2. So what is the present value of this? Can you find me the present value of this mess? Yeah, the present value of this 1 is just 1 because it's already at time 0, plus the present value of this 1 is V because I'm bringing it back 1 period. So A double dot angle 2 is equal to A angle 2 times V. Hang on. A double dot angle 2 is equal to A angle 2 times 1 over V, which is equal to A angle 2, 1 plus I. So in general, A double dot angle N is equal to, at I, is equal to 1 plus I, A angle N, just as we thought before. Every payment is 1 period earlier in this one than in this one. Okay. So I guess we should write that, right? It's the same payment stream. Same payment stream, but every payment 1 year earlier. Every payment is received 1 year earlier in the case of A double dot angle NI. Get it or no? Okay, so the formula for A double dot angle NI is just 1 plus I times the formula for A angle NI. So do you remember the formula? Let's do it. A double dot angle NI is equal to 1 plus I times, what's the formula for A angle N? 1 minus V to the N over I. You remember this from last time? We derived it. So look at this. This I over 1 plus I is another way of saying what? 1 over D, yep. So that this would be 1 minus V to the N over D. So it's kind of easy to remember. When you're talking about A angle NI, you divide by I. When you're talking about A double dot, the double dot starts with a D, you divide by D. Look what I'm trying to say. A angle NI is 1 minus V to the N over I. A double dot angle NI is 1 minus V to the N over D. Every time you write a double dot, you're going to divide by D. The same thing is true for the S's. We know that S angle NI is equal to what? Can you tell me? 1 plus I to the N minus 1 over I. And S double dot angle NI is 1 plus I to the N minus 1 over, what do you think? Right, D. And what's the relationship between this one and this one again? Can you tell me? We talked about it last time. What's the relationship between A angle N and S angle N and A double dot angle N and S double dot angle N? Do you know? S angle NI equals A angle NI times what? One is the accumulated value, one is the present value. So what should I do to the present value to bring it to forecast it n places over? 1 plus I to the N. Exactly right. And you can see that in the formula, can't you? Look at this. If I multiply this 1 by 1 plus I to the N, I get 1 plus I to the N. If I multiply V to the N by 1 plus I to the N, I get 1. You see it or no? That's it. So you don't really have to memorize. You just have to know one of them, and then all of them will follow if you understand. Let's move on. So then, page 3C. A double dot angle NI is equal to 1 plus A angle N minus 1 I. Let's draw a picture. A double dot angle NI is the present value of a stream of n payments, the first one starting at time 0. So time 0 I have 1, time 1 I have 1, time n minus 1 I have 1. So what I'm trying to say here is this 1 is the first payment. And then this is an annuity immediate for n minus 1 periods, meaning these guys. These guys. So let me say here present value of annuity immediate for n minus 1 periods at t equals 0. So I'm saying that these guys are A angle n minus 1 I. That's this, the present value of these payments at this time 0. And then this one is just this one. You see it? Yes or no? Okay, and then how about S angle n plus 1 is equal to 1 plus S double dot angle NI. And there should be an I here also. So let's draw a picture for that one. S angle n plus 1I is the accumulated value at time n plus 1 of payments beginning at time 1. 1 at time 1, 1 at time 2, 1 at time n plus 1. This accumulated value here of n plus 1 payments is S angle n plus 1I. So I'm claiming that this is equal to this one. This one is the last payment of 1. Plus S double dot angle NI. So that S double dot angle NI is this, the accumulated value at time n plus 1 of n payments, but at one period after the last payment. So I'm saying that the accumulated value of these n payments at this time is called S double dot angle NI. Plus this last payment of 1 is this guy. Follow me? And that is equal to S angle n plus 1I. So it's best to understand rather than memorize and such. Because if you don't understand, the problems are going to be a heartache. Okay. So I'm still on page 4. Page 4. Let's do the problem on page 4. I think I'm on page 4. Yeah. This one. A dividend payment of $250 is put directly into Oliver's account at the beginning of each quarter for a year. Okay, so this is important. At the beginning of each quarter for 1 year. Find the accumulated value at the end of 2 years, assuming nominal discount 4.8% convertible semi-annually. A lot going on here, right? So we have to take this apart slowly. Let's draw a timeline. A dividend payment of $250 is put directly into Oliver's account at the beginning of each quarter. So at time 0, time 1, time 2, time 3, $250, $250, $250, $250. At the beginning of each quarter for a year. So this is 4 quarters right here. There are 4 payments, the last one happening at time 3. Find the accumulated value at the end of 2 years. That means 8 quarters. 8 quarters. Assuming nominal discount 4.8% convertible semi-annually. So it's an uh-oh situation because the interest is talking about 6-month interest and the payments are quarterly. 3 months. So I have to find the quarterly rate, otherwise I cannot continue. So let's start with the rate. D, and it's not only that, but it's a discount rate, not an interest rate. Okay, so there's a lot going on. We have to take it apart slowly. The nominal discount rate, 4.8% convertible semi-annually. So D2 equals 0.048. Therefore, D2 over 2 is equal to 0.024. And I don't want the 6-month rate. This is D 1/2, right? Which is the 6-month rate. I don't want that. I want the quarterly discount rate. So there are 2 ways to do this. You could do this directly, like this. I want the interest rate for the quarter and the discount rate for the quarter. You know why I want the discount rate for the quarter? Because my payments are happening at the beginning of the year. So the formula is going to use D in it, right? Because if I talk about A double dot angle 4 or something like that, or S double dot angle 4, either one, it's going to be either 1 minus V to the N over D, and the other one is going to be 1 plus I to the N minus 1 over D. However, I also need the I, because if I talk about S, I need the I. If I talk about A, I need the I. So I need I quarterly and D quarterly for that reason. Are you understanding me, guys? Because the formula uses both. So let's find it. Let's go directly like this. 1 minus D2 over 2 to the minus 2 is equal to 1 plus I4 over 4 to the 4. Right? That's a valid formula. So 1 minus 0.048 over 2 to the minus 2 is equal to, let's just go minus 2 over 4 right here, equals 1 plus I4 over 4. Can you get me a number? I want I4 over 4, which is I 1/4. I'm just asking you to plug this in. And this is a negative 1/2 power over here, because it's 2/4 with a negative exponent. So I'm asking for I quarterly. Can you get me a number for I quarterly? What did you get? 0.01222. That's what I got too. 0.01222044156. And then what is D quarterly? I'm going to need that as well, right? So what is D quarterly? So don't I have a relationship between I and D? What is it? D equals what? What is it? No? D equals I over 1 plus I. So 0.01222044156 divided by 1 plus the same thing. Okay, so I have my I and my D now. What's the value for D? Then what should I do? They want the accumulated value at 8 quarters. Any ideas? How should I get the accumulated value here? Yeah.
Find the cumulative value at 4 and then accumulate it to 8.
Yeah. You see, I can't say 250 S double dot angle 8 because there are only 4 payments. So I better take these 4 payments, get the value here, and then I will grow that to 8. I certainly cannot say S double dot angle 8 because that would imply that there were 8 payments of 250. And there are not 8 payments. There are only 4 payments of 250. So accumulated value at t equals 4 quarters. This is all in quarters for this problem, meaning at 1 year, is equal to 250 S double dot angle 4 at the quarterly interest rate, which is 0.0122204,156. Let's get a number for this, and then let's grow that. Can you get me this number? Guys, I don't even see your calculators out. This is like a joke. Please get your calculators out and work with me. Otherwise, the test is going to be such a rude awakening for you. So can I go like this? 250 times 1 plus I, which is this I, to the 4 minus 1 over D 1/4. I still need a number for D 1/4. Can you get me that number as well? I get 0.01207,288. Did you get that?
Yeah.
Okay. So when I plug this in, 250 S double dot angle 4, remember that you have to divide by D because this is S double dot, not S angle N. It's S double dot angle N. I get a value of 1030.9266. That's the value here. And then I will now grow this. So I can either grow it by 1 plus I quarterly raised to the 4 quarters, or I can multiply it by 1 minus D quarterly to the minus 4 power. They're the same, right? So forecast, or just grow this to time 2 years, grow this accumulated value to time t equals 8 quarters, which is 2 years, by either 1030.9266 times 1 plus I 1/4 to the 4, or 1030.9266 times 1 minus D 1/4 to the minus 4. Get it? And when you do that, either way, you will get 1082.25. That's the accumulated value. So there were lots of things happening in this problem. First of all, they were trying to be tricky by only giving you 4 payments, not 8 payments. Then they were trying to be tricky by giving you a nominal rate convertible semi-annually, not quarterly. On top of that, they gave you the discount rate, not the interest rate. So can you expect something like this on your test? Absolutely. So practice makes perfect. That's all I can say. Okay, let's continue. Do you have questions? Have I made myself clear? My job is to clarify. And if I'm not doing it, you need to let me know. Okay, next one. Perpetuities. Perpetuity is an annuity with an infinite term, meaning that payments are promised forever. The periodic payments represent the interest earned during the previous interest period on some fund, and therefore these payments can go on indefinitely, meaning infinitely. Most preferred stock pay dividends in perpetuity. Many foundations have vast sums of money invested in various securities, bonds, stocks. The philanthropic efforts of these foundations are all funded by interest earned as a perpetuity. Okay, page 5. So if I had to draw a picture of the basic perpetuity immediate, it would look like this. Time 0, nothing, because it's immediate, right? Immediate means first payment at time 1. Just like this, 1, 1, dot, 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 meaning forever. So every time it says basic, it means that the payment is 1. Let A angle infinity, this is an A angle infinity, let A angle infinity I be the present value of a perpetuity immediate one period before the first payment with effective interest rate I over each payment period. And let A double dot angle infinity I be the present value of a perpetuity due. So it's just like our regular perpetuity, our regular annuity immediate and annuity due. The double dot represents due, the no double dot represents immediate. So look at this formula right here. Notice that A double dot angle infinity I equals 1 plus A angle infinity I. Here's the due. This is immediate. And this is due. Forever. Dot, dot, dot. So this one is saying that A double dot angle infinity is 1 plus A angle infinity. It's just one more payment. You see, these payments are these payments right here. And then this one has one more at time 0. So here, the present value equals A double dot angle infinity, and here the present value equals A angle infinity I. That's the difference. So this is saying if you count the first payment, plus the present value of the annuity immediate, you will get the annuity due. So how about this formula right here? A angle infinity I is claimed to be equal to 1 over I. Can we show that? You can show it 2 different ways. One way is to do the cop-out way, which is we know that A angle N is equal to 1 minus V to the N over I, right? That's equal to 1 minus 1 over 1 plus I to the N over I. What happens as N goes to infinity? A angle infinity equals limit as N goes to infinity of A angle N. Take the limit as N goes to infinity. What happens to this term right here? 1 over 1 plus I to the N. Yeah, this one goes to 0 as N goes to infinity, because the denominator gets bigger and bigger and bigger, and 1 over a very big number goes to 0. So in the end, you just have 1 over I. And you also had A angle N, A double dot angle NI is equal to 1 minus V to the N over D. We know that formula too. So A double dot angle infinity I is equal to 1 minus 1 over